Okay, sorry for the delayed start. I'm just having problems with PowerPoint and trying to get things saved, and I think it's related to not being able to print as well. I'm not sure what's going on. Anyway, welcome everyone to week 6. So before we move on to a brand new topic, so essentially everything that we've covered up so far is all about prediction, well, mostly I guess focusing on prediction modeling, but epidemiological models is applicable as well. And so that's kind of now finished, and we're going to move on to a brand new topic area for the rest of this semester, which is looking at how to analyze correlated data. But before I do that, I think it's a good time now to ask any questions you have that might be related essentially to the assignment and just general prediction modeling. Yeah.
I have a question about the timing of looking at fractional polynomials. So if in the univariable stage we find that one of the variables is highly skewed and the lowest curve is non-linear, then at that point should we start thinking about fitting a fractional polynomial and then using that fractional polynomial throughout the model building process and then kind of rechecking it again when we're looking at linearity?
Yeah, that's an excellent question, and someone has asked the same question this afternoon. And I think a lot of other people are wondering this as well. And there isn't one way to do this. It does get a bit tricky when we start to look at linearity early on and then go, what do we do? So you could check linearity at the univariate stage by doing the lowest thing, indicates that actually it's clearly non-linear. You could fit a univariable fractional polynomial, and that supports the fact that it's non-linear. The problem is, and then at that point you could actually create a fractional polynomial for that variable. The problem is when you put it into the multivariate model, that shape may not be the most correct shape anymore. And that's the challenging bit, is, well, how do we handle this? So the ideal way to handle it would be to go right from the univariable analyses. We know it's not linear and the p-value is less than 0.25. So we know that variable has to go into the multivariate model. Ideally, what we want to do is just work out from the univariate stage what is going to go into the multivariable model. And of course, the first thing then to check is all of those variables which are going to go in, check the collinearity. And of course, we've got a collinearity command now where you can do that without actually fitting a model. So you can first check collinearity and just make sure that there's nothing there that we need to remove straight away. And then when we fit our first multivariable model, the way that we ideally want to do it is have all our variables in, work out what is the right shape for each of our continuous variables, and then once we've got those shapes correct, then we look at the p-values and then drop the variable with the highest p-value. That's the ideal way to do it. So it is a slight shift to what I've taught you before or previously in those steps. And my understanding is that MFP will do that for us automatically. It will actually go through with all the variables in the model, work out what the right shapes should be, and then it will drop one variable at a time. That's my understanding. So you could just use MF, even though in one of the notes I say this is optional reading. If you understand fractional polynomials and what they're doing, I think the MFP is actually quite a nice command to use, and then it does make your life a lot simpler. If you're not comfortable using MFP, I think it's adequate. It's not going to be perfect, but it is adequate to say, look, I'm going to start my multivariable model where I'm just simply going to assume linearity and then do my multiplicity process on that. And then once whatever's left, I'm going to do the fractional polynomials. There's some flexibility here. There's there's no hard and fast rules. You might, for example, when you look at your data, it's very highly skewed. You look at the univariable fractional polynomial, and it may not say that the best one is a log. It may say the best one is a log, which might say to you at that point, given that it's just so skewed and that it does seem to have a logarithmic shape, I'm just going to put it in as a logged transform variable and do my model building based on the log transform, and then I'll just recheck the linearity of the log transformed variable, or I could unlog transform it when I check the linearity assumption if I wanted to. You could do it that way. So there's lots of different possible ways, but I don't want to make it so confusing for you that you don't know which way to go. But I do want people to start. So you're asking the right sorts of questions in my mind. So this course is about thinking and just having to you've got to come up sometimes with what you think is the most sensible strategy. So I can give you guidance, but really a lot of this course is actually saying, well, let's think about it and let's think through what are the options. And I think this one makes more sense. That's what I want. I want people to actually think and justify what they're doing. Often there is no perfect solution. I'm sorry.
So as long as we kind of justify what we're doing along the way and explain our thinking, that's really what you're looking for.
Yes.
Yeah.
Absolutely. Yeah. I mean, if you explain your thinking and I really disagree with your thinking, I can't guarantee that you won't be penalized, but you're more likely to get some points for, okay, I can see where you're coming from here. But there are definitely situations where it's just like, actually, you know, I don't really know what the best solution is here. I mean, in some sense, I'd love somebody to go, actually, no, this is what I've decided to do. I said, I haven't even thought about that. Fantastic. Yeah. Questions? More questions?
So if we get the shape we're looking for from the univariable analysis about the variable, and then we use that term in the multivariable analysis, can we check at the base model, just the base model, and if it's the same term, can we just keep continuing until we get the final model and then recheck again? There is any possibility it's going to be the same fraction from the multivariable to the univariable at the first stage, at the base model?
So that's hard to do. So, I mean, yes, what you could do is put into your first multivariable the fraction polynomial from the univariable, but think it through, though, in the sense of then how are you going to check whether that's the right shape? And the way to check that is to refit that as a fractional polynomial, so which means that you wouldn't use the fractional polynomial from the univariable. This is what I'm sort of saying. Yeah. I'm probably giving too much away here. This is what I want you guys to think through for the assignments. So it's a little, I know it's probably not very popular, and I hope people don't slate me in the rating of this, but it, you know, we're being very good in teaching you kind of very clear steps, but there gets to a point when things get more complicated that I can't prescribe to you every single step, and that you will need to make decisions and think things through independently. And I think that is appropriate at this level. By all means, voice what you think, and I'm happy to say whether I think your thinking's good, or whether have you thought about this, or maybe this is the way that I would do it. But it is about, you know, this assignment may seem quite daunting, but the whole point of this assignment, I think, is doing exactly what I want it to do, which is to get you guys thinking. And you might be going, but Patrick hasn't given me the answer to this. Well, maybe that's true, but is that a bad thing, you know?
It's fair enough. So yeah, thank you.
Okay, any other questions? Okay, so another question that was asked to me today was about categorical variables. And in categorical data analysis course, if the categorical variable was ordinal, you could fit it as a continuous variable. And do you need to do that here for this assignment in this course? Or is it okay just to fit a ordered categorical variable as just simply a categorical variable? And the short answer is yes, that's absolutely fine. To be honest, I hardly ever fit ordered categorical variables as continuous. I always tend to fit them as categorical, but that's just me, and in some sense I probably should look at fitting it as continuous, but you're not going to be penalized if you just keep things as categorical, even if they're ordinal. And of course, if you've done survival analysis, you could also do it. You would know how to do a proper linear trend test. And I don't know whether I confess, I don't know whether you get that covered in categorical or not. So I have a confession that I never do the test for linear trend tests for survival analysis. It might be to do with the way that I was taught survival analysis, so it just never comes into my brain to actually do that. So like I say, the short answer is that no, you don't need to fit it as continuous. Okay, any other questions? All right. Okay, so let's move on to a brand new topic. Which is looking at how to analyze correlated data. So I'm going to explain to you what correlated data means, and then I'm going to present to